graph the rational functions. So there's a step-by-step procedure for graphing the rational functions. Step 1, we find the y-intercept and the x-intercept, if any. Step 2, find the vertical asymptotes. Step 3, find the horizontal asymptotes. And then step 4, you draw the graph. So we use this example to graph the rational functions. So the first step, we find the x-intercept and the y-intercept. So finding the x-intercept, we let the y equal 0. Y is here, your f of x is y. So I'm going to rewrite it into x squared minus 4 over x squared minus 1, set that equals 0. Now you can diagonal multiply, or you can multiply x squared minus 1 to the both sides, so that here will reduce. Now x squared minus 4 equals 0, because 0 multiply any number, you still get a 0. So x squared equals 4. So that means x equals positive negative 2. So you have two x-intercept. One x-intercept at 2, 0. Another intercept at x equals negative 2, 0. Finding the y-intercept, we let the x equals 0. So we substitute the 0 back to the function. Now you have 0 squared minus 4 over 0 squared minus 1, which is negative 4 over negative 1. So it's 4. So 4 is your y-intercept. So your y-intercept coordinate point at 0, 4. Step 2, we find the vertical asymptote. Finding the vertical asymptote, we need to get the simplest form, right? Simplest form. And then we set the denominator equals 0. Equals 0. So when I look at this function, f of x, the numerator here, I can rewrite the binomial form into the x plus 2 times x minus 2. The denominator here, I can rewrite into the x plus 1 times x minus 1. Sorry, this is 2. So when I look at the numerator and the denominator, I realize there's no like term I can reduce, right? So there's no need to take the factor form. So we can just keep this one by finding the horizontal asymptote. So since the simplest form we checked already, now we just let the denominator equal 0. So I write down the x squared minus 1, set that equals 0. So x squared equal 1, that means x equal positive negative 1. So you have two vertical asymptotes at x equal 1 and x equal negative 1. Now we do the step 3. Finding the horizontal asymptote. Getting the horizontal asymptote, we need to consider the highest degree power on the numerator and the denominator. So since both of the term, they have the same denominator, they have the same exponent, right? So 2 equal 2, in that case, the horizontal asymptote is equal 1 over 1, which is y equal 1. That is your horizontal asymptote. So let me write down the horizontal asymptote is y equal 1. So now we can sketch the graph by putting all the information together. So I'm going to draw the horizontal asymptote at y equal 1. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So now we have the horizontal asymptote at y equal 1. So I'm going to draw the horizontal asymptote the dotted line passing to the y equal 1. Vertical asymptote, we have two vertical asymptote at 1 and -1. So let me use the red color. So we have two vertical line, vertical dashed line passing to x equal 1 and x equal -1. So this is x equal 1, x equal -1, and this is y equal 1. Now we have all the asymptote line ready. We go back to look at the x-intercept and the y-intercept. X-intercept at 2 and the -2. So I'm going to label the dot here. Let me use another color. So I have the curve passing to x equal 2. The curve also passing to x equal -2. So these 2 points, the graph will pass into it. Y-intercept at y equal 4, right? 0, 4. So I'm going to plot the point y equal 4. This will be the y-intercept. Now, as here you can see, the vertical asymptote gives us the information the curve never ever pass into it. The curve never can cross the vertical asymptote. So we have two x-intercept here. This is a y-intercept. And we have the horizontal asymptote and the vertical asymptote here. So that means I will have the curve, it will just very close to the vertical asymptote. And when you go to the positive infinity, it will always below than y equal 1. That would be the end behavior. When this curve go to positive infinity, it will very close to the y equal 1. Same way with the left-hand side direction, the curve will pass into x equal -2 and it will keep going down forever along with the x equal -1. Same way, when the curve toward to -infinity, the y value will very close to the y equal 1. Now, this point here, this is a y-intercept. There's a two vertical asymptote here, one horizontal asymptote here. This point, the curve never go down. It won't go down to cut through the horizontal asymptote. So only way it will go to will be going up forever to go to the positive infinity. So this is a graph. You will see that of this function. Now, we do the example of this one. This is a question from your homework. Find the equation of the vertical and horizontal asymptote of the graph. So the vertical asymptote, here we have two vertical asymptote, right? So x equal 5 is the vertical asymptote. X equal -5 is another vertical asymptote. So you have two vertical asymptote. So x equal 5 and a -5. Horizontal asymptote, this is a horizontal asymptote, right? So y equals 0 would be the horizontal asymptote. For the vertical asymptote, I'm not sure whether you have to put a -5 on the left-hand side and +5 on the right-hand side. But if the program asks you to do that, you just reorder the pattern. Put a -5 here and then put a +5 on the right-hand side. Finding the domain and the range. If you look at a graph, the domain it will keep going to left-hand side forever, which is -infinity. And when the graph comes to the -5, it has a vertical asymptote. So this would be one interval. And then let's skip the -5. And then after -5, it will continue go to +5. This will be another interval. And then skip the 5. Then continue from the 5 to the infinity. So this would be the domain of the function. Range. The range is the lowest point to the highest point. It has the horizontal asymptote here. So the range, it will keep going down forever, negative infinity. So your range would be negative infinity up to 0. Put a union. Then from after 0, it will keep going, go to positive infinity. Because the curve here, it will keep going up forever. So this will be the range. Finding the horizontal asymptote, if any, of the rational function. So we do the practice of this one. Horizontal asymptote, we'll compare the degree power, right? So this horizontal asymptote at y equal 1 over 4 because the degree power is the same. This one, the degree power numerator is less than denominator. So your horizontal asymptote at y equals 0. For this one, there's no horizontal asymptote. Finding the domain of the rational and the vertical asymptote. So domain of this one, we just simply just set a dx plus 7 equals 0. So your dx equals negative 7. That means x equals negative 7 over 3. So you can pick whatever point you want, but not this point on your x-axis. You have to avoid this point. So here's negative infinity, here's a positive infinity. So your domain of this one, you will have the negative infinity up to negative 7 over 3. Then union, from negative 7 over 3, go to positive infinity. Vertical asymptote, it's the same way you set the denominator equals 0. So your vertical asymptote at x equals negative 7 over 3, you see that's the reason why at that point there's a gap. The domain of this one, we set the denominator equals 0. So from here, we get x squared equal 49, which is x equal plus minus 7. So if I draw the number line, we have to give these 2 points and negative 7 and 7. So the domain of this one, you will have the negative infinity up to negative 7. Union from negative 7 up to 7. Then union from 7 to the infinity. Vertical asymptote, before you finding the vertical asymptote, we have to make sure we have the simplest form, right? So you have x minus 7 over the denominator here. I can rewrite this binomial form into the x plus 7 multiply x minus 7. Now x minus 7 over x minus 7, they reduce. So the only term you have now is 1 over x plus 7. So from here, we can find the vertical asymptote. The vertical asymptote at x equals negative 7. So this is a vertical asymptote. X equals negative 7. Finding the domain of this one, we did that ax squared plus 3 equals 0. So ax squared is equal to negative 3. X squared equals negative 3 over 8. That means x equals positive negative root 3 over 8. I have the negative sign, and I bring to the outside 10 to the I value. Now, this is an imaginary number. We cannot find these 2 points on your number line.